almost 75,000 circuit miles of 69 kV overhead lines in the United States, it's vitally important that this backbone voltage of the nation's electrical system give maximum continuity of service. This movie will assist in maintaining that service by instructing hot stick crews on the safest, most efficient, and most practical methods of working on 69 kV single-pole suspension construction. The first job will involve moving all three conductors on a Z-type structure. After the lifting wire tong and its supporting lever lifts are installed, then the holding wire tong and the wire tong saddle are installed for the first conductor. A set of rope blocks and an insulated spiral link stick are then attached to the conductor, with the blocks being hooked above the brace just under the arm. A little slack is taken up on the blocks so that the cutter key can be pulled and the insulator string disconnected from the suspension clamp. The blocks are slowly released to lower the insulated spiral link stick so that the conductor is moved out to a safe working position. The saddle clamp, which supports the holding tong, is then locked to hold the conductor securely. The spiral link stick is then removed from the conductor. The lifting wire tong is installed on the second conductor with the butt ring hooked to a lever lift. In this case, the conductors were pushed out slightly with the lifting wire tong, eliminating the need for blocks on the lifting wire tong. By doing this, as the blocks are tightened on the spiral link stick above, this will pull the insulator string back in a straight vertical position, providing the slack necessary for unhooking the insulators from the conductor. The holding tong and saddle are then attached and the cutter key pulled. The conductor is lowered to a safe position, the saddle clamp locked, and the blocks and insulated spiral link stick removed to be used on the top conductor. Since the lineman has to get above the top conductor to fasten the blocks and sling line around the pole, this lifting wire tong will be put in place on the lever lift, and a pair of blocks will be used to push the top conductor out. Pushing the conductor out in this manner gives approximately a foot more climbing clearance for the lineman to go above and attach the blocks. Now that the blocks and insulated spiral link stick have been attached, the wire holding tong and its supporting saddle are installed, and the conductor brought back to its normal position for pulling the cutter key and disconnecting the insulator string. The cutter key is pulled, and the insulator fork used on the bottom insulator to assist in disconnecting the insulator string from the conductor. Since more clearance will be needed here, the blocks are used to lift this conductor up as it's moved out to clear the top of the Z-arm. Blocks are tied off by using a rope snubbing bracket at the pole base while the conductor is held in the clear, giving the lineman plenty of room to remove the insulators or arms and replace them. The reverse procedure is used for bringing the conductors back in position. First, the insulated spiral link stick is attached to the top conductor. The conductor is then moved back to the suspension clamp. Now that the insulators have been attached to the suspension clamp and the cutter key hammered in place, The blocks on the bottom of the lifting wire tongue will again be tightened to give the lineman more clearance while removing the spiral link stick from the conductor and untying the sling line with a tie stick to lower it down in position for the next conductor. A tie stick is used to untie the square knot in the sling line and pull it down so the lineman does not have to climb above the arms to remove the blocks or the sling line. The second conductor is brought back by using the insulated spiral link stick and blocks to pull it back in position for attaching to the insulator string. Now that the ball and socket fittings have been hooked together, the cotter key is hammered in place and all tools are removed from this conductor. By use of a tie stick, the blocks are unhooked from the sling line up above, and the same tie stick is used to untie the square knot and pull the sling line down within easy reach of the lineman without having to climb above the arm. Note the tool holder attached to the crossarm. It's much safer to hang hand tools on the arm than on conductors where they can be accidentally bumped off. The tools are then removed from the second conductor. The third conductor is brought back in the same manner with the blocks and insulated spiral link stick. These are the tools that were used on this Z-arm type construction. These are the 3 lever lifts used on the lifting wire tongue. This is the rope snubbing bracket used at the bottom of the pole for tying the block lines. These 3 saddles were used for supporting the wire holding tongues. The 3 2 1/2 by 12-foot epoxy glass lifting wire tongues. The 2 1 1/2 by 10-foot and the 1 1 1/2 by 8-foot epoxy glass holding wire tongues. The tie stick used for handling the blocks and the insulated spiral link stick. The universal sticks with the cotter key puller and insulator fork. This is one set of blocks used on the top of the pole with the sling line. This is a crossarm tool hanger, an insulated spiral link stick, and the other set of blocks used on the lever lifts and the lifting wire tongues. This is the ball socket adjuster, used to assist in disconnecting the socket clevis fitting from the insulator string. These These same basic tools can also be used on the next job to be pictured, removing all three conductors on the two-arm type of suspension construction. The rigging of the holding and lifting towings and the supporting lever lifts and saddles are handled in the identical manner as was used on the Z-arm construction. You will notice that both of the bottom conductors have been pushed out, giving a lineman more climbing clearance for attaching the sling line and the set of rope blocks for handling the weight of the conductors with the insulated spiral link stick. Now that the blocks have been put in position, the first conductor to be moved is then lowered back into place. An insulated spiral link stick is placed on the conductor to help handle the conductor weight. This close-up from an aerial bucket shows the disconnecting of the insulator string and the lowering of the conductor. This overall shot again shows the movement of the first conductor. The blocks and insulated spiral link stick are then removed and swung around to the second conductor on the arm. The counter key is pulled on the second conductor. The insulator string disengaged from the suspension clamp, and the conductor moved out to a safe working position. The overall view shows the movement of the second conductor. The linemen then move on to working the top conductor. The lifting tongue is clamped on the conductor and fitted into the lever lift. The insulator string is moved out slightly so the lineman can move into a more accessible working position. The holding tongue and saddle are applied, and the insulated spiral link stick is placed on the top conductor. This close-up shows the pulling of the cutter key, the disconnecting of the insulator string, and the movement of the conductor. To get more clearance from the end of the bottom arm, the blocks on the lever lift are tightened slightly as the conductor is moved. Now that the repair work has been finished, all conductors will be brought back into position. The ball on the bottom of the insulator is attached to the socket clevis fitting on the suspension clamp and the cotter key hammered home. This same procedure is used on all conductors using the lever lift for supporting the weight of the conductor from the lower position and the set of rope blocks and insulated spiral link stick for supporting the conductor from the top position. The cotter key is hammered in on the second conductor, and the insulated spiral link stick and the holding tongue removed. The third conductor is moved back to the insulator string. An adapter on the end of a universal pole is used to guide the socket on the suspension clamp onto the ball of the insulator. The other lineman holds the insulators with an adjustable insulator fork. This is an overall view of the movement of the third conductor. It was not necessary to use blocks on the lever lift on these two bottom conductors, as the conductors were pushed out slightly with the lifting tongs so that the load was lifted on the blocks above. Here, the sling line and blocks are removed with the tie stick so the men do not have to climb above the arm. The crossarm tool holder is then removed with the tie stick. This third job shows the procedure for changing a crossarm on the bottom phases of a two-arm construction 69 kV line. A link stick with a side line is attached to the conductor. Saddle blocks anchored to a nearby pole are used to pull on this conductor, so the insulator string will hang vertically, giving the men more climbing clearance and also making it easier for disconnecting and pulling the conductor in the clear after it's been disconnected from the insulator string. The lifting wire tongue is placed on the conductor and the lever lift attached to the pole. The saddle blocks are attached to the lever lift. Another set of blocks and insulated spiral link sticks are used to handle the weight of the conductor for raising, lowering, and positioning. The cotter key is then pulled while weight is still on the insulator string. Blocks at the top are tightened to gain enough slack for disconnecting the insulator string from the conductor. After the conductor has been disconnected, the sideline and insulated spiral link stick are then used to pull this conductor out to a safe working distance. The blocks on the sideline are then tied off to hold it securely. The insulated spiral link stick and blocks are removed. The blocks and insulated spiral link stick are then placed on the second conductor. The insulator string is pulled straight up and down before installing the lifting wire tongue. After the wire tongue is tightened onto the conductor, the lever lift is then placed in position and the hand wheel on the tightener is tightened. The top set of blocks is then pulled or tightened, bringing the conductor in and up to gain slack for disconnecting. The conductor is then moved out to a safe working position, and the block line is tied to a rope snubbing bracket at the butt of the pole to hold this in the clear. After the arm has been changed, the conductor is brought back in position where the insulator fork and the ball socket adapter will be used to reconnect the insulator string to the conductor. The cotter key is hammered in place. The second conductor is then brought back in position for connecting to the insulator string. All of the sticks can then be removed. The conductor on the outside angle is then moved back into its normal position where the link stick will be removed and lowered to the ground. Now a close-up look at the tools that were used on this job. This is a lever lift with the wind-up tightener. This is a rope snubbing bracket used at the butt of the pole to tie the block line. This is the lever lift with the lever-type chain binder. These are the two epoxy-glass lifting wire tongs. This is a tie stick used to place the spiral link stick on the line. And these are the two universal pulls with the pry-type cotter key puller. And the adjustable insulator fork. This is a 1 1/4 inch by 4 foot link stick used to pull the outside angle on the conductor with the sideline. This is a spiral link stick used with the blocks for picking up the weight of the conductors. This is a set of blocks used on the sideline with swivel hooks. This is the sling line used at the top of the pole for attaching the blocks, and the insulated spiral link stick. All the rope used in the blocks, sling lines, and hand lines was polypropylene, which is considered an excellent rope for use with hot line tools. This is a crossarm tool hanger used to hang the hand tools on the crossarm. This is the set of blocks that were used on the lever lift and lifting wire tong. This is a ball socket adjuster used to disconnect the socket clevis fitting from the insulators. Throughout this movie, you probably noticed the deliberate working speed of the linemen and constant attention to safety practices. The combination of well-designed tools and well-trained linemen enables America's power companies to maintain lines safely while keeping the kilowatts at work.